Into it. This is your high-density guide designed to lock in your entire Pure Maths 1 knowledge for exam success. We're not just reviewing here, we are building a complete blueprint for you to get that A star. So here's our game plan. First, we're going to deconstruct the exam itself and make sure our core algebra skills are rock solid. Then we'll dive into the big topics: quadratics, all that advanced algebra, and of course, calculus. And to finish, we'll arm you with a powerful formula and strategy guide that you can take right into the exam hall. Okay, let's dive right in. Look, to score in the top bracket, you've got to understand the game you're playing. That means knowing the structure of the P1 paper inside and out, and truly mastering the algebraic skills that, let's be honest, pop up in absolutely everything else. Now take a really close look at these weightings. Your ability to just recall and use the right techniques, that's AO1, and build logical arguments, AO2, that right there can be up to 86% of the entire paper. So what does that tell you? It means that nailing the standard methods flawlessly is your main path to a top grade. These rules, yeah, they're completely non-negotiable. Think of them as the basic grammar for P1. They're not going to ask you a simple question about them. No, they're going to hide them inside a big, scary calculus or geometry question. You have to be the one to spot that a denominator of, say, 3 plus root 2 needs to be rationalized by multiplying by its conjugate, 3 minus root 2. Getting these moves down cold is absolutely essential just to get started on the tougher problems. And this right here, this is where so many easy marks just disappear. You see the trap on the left? The student forgot to apply the power to the number, the coefficient. The correct way shows you have to apply that outside power to every single thing inside the bracket. You've got to be methodical. You've got to be precise. Okay, so with that algebra foundation nice and secure, let's see how it actually applies to the core visual topics of the course. You know, quadratics, sketching all those graphs, and using the powerful tools of coordinate geometry. So, the discriminant, b squared minus 4ac. It is so much more than just a piece of the quadratic formula. Think of it like a crystal ball. It tells you exactly how many times a line and a curve are going to cross, or if a quadratic graph even touches the x-axis at all. And it does all that without you ever having to solve the full equation. It's a massive shortcut. Now listen up, because this is a huge one. This is straight from the examiner's reports. When you're completing the square and that number in front of x squared isn't a 1, you absolutely must factor it out from the x squared and the x terms before you do anything else. So many students trip up on this, and it's such an easy way to lose marks. Just remember this one simple bit of logic for transformations and you'll be set. Anything happening inside the function's bracket messes with the x-coordinates, and it usually does the opposite of what you think it will. Anything happening outside the bracket messes with the y-coordinates, and it behaves exactly like it looks. And here are your essential tools for coordinate geometry. You just have to have these memorized. No way around it. That perpendicular lines rule is so important. If you know one gradient, the other one is just its negative reciprocal. So, for example, if one line has a gradient of 3, the line perpendicular to it has a gradient of negative 1/3. Simple as that. Okay, time to gear up. We are now heading into the tools you're going to need for the more complex problems. Things like handling inequalities correctly, using binomial expansion, and of course, the fundamentals of trigonometry. Whoa, stop, and look at this very carefully. Trying to solve a quadratic inequality like it's just a regular equation like you see in the trap column is almost guaranteed to get you the wrong answer. The only foolproof method, the only way to be sure, is to find your critical values first and then draw a quick sketch of the parabola to see which regions are actually the ones you're looking for. Right, binomial expansion. The formula itself is in your formula book, that's the good news. But knowing how to use it, that's the real skill. You have to be incredibly careful when you substitute. If you're expanding something like, say, 2 minus 3x to the power of 5, your a is 2 and your b is negative 3x. Forgetting that minus sign or the 3 in front of the x is such a classic error, and it will cost you every single mark for that part of the question. These two identities right here, they are your master keys for all of trigonometry in P1. I promise you, almost every difficult trig proof or equation is specifically designed to be unlocked by a clever use of one of these two. The whole game is usually about using them to turn a messy equation with sines and cosines into a simple quadratic that you already know how to solve. And now we get to one of the most powerful tools in all of mathematics, calculus. For P1, it really boils down to two big ideas that are opposites of each other: finding rates of change, which is differentiation, and finding areas, or how much of something has built up, which is integration. The big idea here is that they're just inverse processes. For differentiation, you multiply down by the power, then you reduce the power by 1. For integration, you do the reverse. You increase the power by 1, and then you divide by that new power. But, and this is the absolute number one rule, you must rewrite things like square roots or fractions into index form, like k times x to the minus 1/2, before you can even think about applying these rules. This is probably the easiest mark to get on the entire exam paper. And believe me, it is the most painful one to lose. Every single time you do an indefinite integration, you have to add that constant of integration, the plus c. Just make it a reflex. The second you write the integral sign, get ready to write plus c at the end. So let's see how all this stuff comes together in the real world, or, well, the exam world. This is a totally classic exam question, Q4 from a past paper. It's built specifically to test your algebra, your differentiation, and your integration skills all in one go. See how this works? This breakdown shows you how these multi-part questions are designed. Part A is just pure algebra, using your index laws. If you get that right, parts B and C are just, well, they're just straightforward applications of the calculus rules. But if you make a mistake in part A, it creates a domino effect, and you'll lose follow-through marks. So always double-check that initial algebra. Okay, we've covered all the content. Now let's switch gears and talk about pure exam performance. This is where we consolidate all the must-know formulas and give you a rock-solid battle plan for exam day. Go ahead, screenshot this slide right now. These are the absolute 100% non-negotiable formulas for P1. Yeah, some are in the formula book, but having them burned into your memory gives you speed and confidence when the clock is ticking. These are your tools. You need to know them inside out. This structured approach is how you win. Don't just start at question 1 and grind your way through. No, you bank the easy marks first. Get them done. Build a solid score, boost your confidence. Then, with most of the paper already in the bag, you can go and attack those tougher questions with a much clearer head. So, let's finish on this question. You've learned all the content. You know the formulas. You've got a killer strategy. What's the final piece of the puzzle? What's the one thing that separates the A students from the A-star students? It's this. It's your ability to do everything we've just talked about with near-perfect accuracy when the clock is ticking and the pressure is on. Just knowing the math isn't enough. Performance on the day is everything. And the only way you build that performance is through relentless practice of timed exam papers. That is the blueprint for an A-star. Now go and practice.